Everyone, I hope my voice is audible. And there is some issue. Let me see how I can fix it. Hello, hello, hello. Start. Hello, hello. Voice check, voice check. Is my voice all good? Is my voice all clear? Yeah, I think now my voice is better. Okay. So this today's stream is going to be, I'm going to solve a lot of coding problems. I'm gonna practice along with that. I think what I'm going to do is I'm going to solve all of these which are here, and then I will take a look at advanced also. I want to solve try questions also, and then backtracking also. A lot of questions that I want to solve, but we'll start with this. Number of islands given in an cross arm which represents 1 and 0 is written on the number of islands. So basically an island is surrounded by water, all the ones, right? And so all the ones will form. Yeah, the voice is okay now. Hello. Voice check, voice check, voice check. Cool. I'm not very much about the voice, and the timer has started for 16 minutes. And okay. Number of islands, right? So basically this problem is like this. So you have ones, right? So these are all the islands, right? We want to find number of islands. All the connected ones form one island, right? And you can go in four directions. Basically, this also comes here. So when it comes to graph problems, right? There are mainly two ways, DFS or BFS, right? Now DFS is depth first search where you go down all the way you can find. In BFS you explore one neighbor at a time, right? This is generally used when you have to find the shortest path because you start from here, you explore all the directions and then explore all the directions. This depth first search is when you want to go down, right? So basically here we will do use the DFS, right? And once we have kind of visited one, we don't need to visit again. So we'll start in this way. char, grid, and tie in J. Now, in here basically, so we are at I and J, right? I need the ends of this grid 0 dot length. Now, if I is less than equal to n or j is less than equal to m. Now, basically, if I is less than 0 or j is, we can go in four directions. We can only go horizontally and vertically, right? J is less than 0 or I is greater than equal to n or j is greater than n or then you return 0, right? Now, that is the case here. So basically, uh, right now you do a DFS. So if grid of I comma j is equal to 0, then also you basically return from here. And this doesn't have to return anything, I think, because yeah, we don't need any return type, right? And then you can go in four directions. So I'll create directions in this way. Right now I can go in four directions. 4 in d is equal to 0, d less than 4, d plus plus. And if uh, grid of so now new element, right? So I is equal to dx of d plus I and jj is equal to dy of d plus j, right? Now if dfs of grid, so basically you will do the same thing on dfs of grid and j, right? So if it is not, if it is 1, so now you will mark it as 1, 0, right? Mark it visited, and then you do the same thing on that. So I, j, j, right? All the four directions. And here, if grid of I comma j is equal to 1, so basically you can do DFS on this, right? DFS grid I comma j count plus plus. So I'll call it islands 0, islands plus plus at an island. So this is basic DFS. Here I need to do DFS. So time complexity of this would be we are traversing each n square. Time velocity of this solution should be n square, right? So this is the first problem that I have solved. 2000. How to keep it open. Max area of a triangle, right? So you are given m cross n binary matrix and island is ones representing curve. You may assume that all the flows are surrounded water array. So max area. This is similar to what? This is very much similar to what we discussed earlier also, right? So you have, let's say, is there a smaller one? Let's say you have like this. So basically biggest one, so number of ones in that, right, and each connected component. So now I want to solve this and quickly the public int dfs gradient I int j. So int time is equal to grid dot length, int time is equal to grid dot 0 dot length for if I is less than 0 or j is less than 0 or I is greater than equal to n or j is greater than equal to 1, we basically return 0. If grid of I comma j is equal to 0, then also basically you return 0. Otherwise you make it 0 and then you go in four directions, right? So int dx, the direction, and then dy. So for t is equal to 0, d less than 4, t plus plus f int. Now here we need max also, right? Int max is equal to 0, basically 1, right? For this, now you will say max is equal to max plus solve, not solve, dfs of grid dx of d plus I, dy of d plus j, and then we say return max, and int max area is equal to 0, or int I is equal to 0, I less than grid dot length, g plus plus for int j is equal to 0, j less than grid dot length, j plus plus, this is also 0, if so basically here if grid of I comma j is equal to 1, max is equal to max dot max of max by dfs of grid of I comma j, right? And then you return max area, max area, max area. So this was, so as of now we have been doing only dfs first. This is all based on dfs. This is plain dfs that we have been doing. So we are learning about graph algorithms, and we have been solving DFS as of now. DFS, right? So clone graph, you are given a reference of a node in a connected undirected graph. Connected undirected graph, right? So basically, so I'll so basically as of now we are doing DFS, right? So I'll little bit go up and I'll start from here so that I can come back to that, right? So we'll come back to this. Basically, I'll come back to this graph algorithms. This is important that we are studying today. Okay. Now this problem, right? So they are saying that you are given a reference of a node in a connected undirected graph, right? So there is no edge. Edge is like this both directional, right? Bidirectional. And then they are saying that each node, it has a value and it has neighbors, right? So each, okay, value is 1 comma 2. Now the graph that has been given to us, 1 second. Wow. So the graph that has been given to us is the first node 1 that has neighbors 2 comma 4, then 2 has neighbors 1 comma 3, 3 has neighbors 2 comma 4, and then 4 has neighbors 1 comma 2. Now I need to do a clone of the graph, right? And there is no root, so anything can be root because it is connected, right? This connector is important here. Now how can I do that, right? uh, Basically, so for each node, for this copy we have to create a new node, right? And whenever I create a new node, that is understood, right? That I need to create a copy of this node, and in the end I need to pass any value, so I can start from this and pass that node basically, because it is connected. So from this node, I can go to 2 and I can go to its neighbor. And then when I go to this 2, for this 1, I have already created node and a hash map. For this 2, I'll come back to 1 and I have a link to 4 also. If this 1 is already explored, right, then I can just add that element back. Then I can just add that element back. So basically what I'm trying to say is open for 1, 2, 2, 4. If this element is not created, you create a new element, and then for all its neighbor, you need to add these elements to this neighbor also, right? So you go to 4, you say that okay towards 4, 4 is not there, you create a new node, and then you go 4's neighbor. But 1 is already there, so you return back to 1. So it is going to be like you need to have a hash map. So hash map node to node mapping. Now public do DFS on node hm. Now if hm dot contains key node dot value, right? If it contains, then you return hm dot get node dot value, right? If it doesn't contain, like say 1, so you say node new node equal to new node node dot value, right? And then you put also hm dot put node dot value comma new node. So this can be integer because all the elements are new, right? So node dot value. Now once you've done that, right? So let's say you have added that element. Now what else you can do? So now you need to add. So you have created copy of 1, but you need to add its neighbor also, right? For node name in node dot uh, neighbors, right? Neighbors. Right now for each node, we don't want to add that node, right? We want to add the other node, right? So new node dot neighbors dot add dfs of name and hm and return new node. So basically what would happen is if this is already there, then you add that because you have already towards you don't need to do. In the end you will return dfs of node comma hm. Yeah. New node. So hm dot contains key node dot value. It is saying that uh, it could be null. Okay, node itself is null, right? Okay, okay. So basically, if node equal to null, return node. Edge case, I missed one edge case. That node could be null only, right? Yeah, that's a good edge case. Okay, that sounds good. So this is again DFS problem, right? And I think this is a premium problem, and let's show rotten oranges here. So number of islands, max area of island, just adding all these problems to the description and graph. Okay. Uh, so you are given, so rotten oranges. So basically you are given M cross N grid, right? And where each have one of three values, 0, 1, 2, right? And I want to change the color of it, right? So 0, 1, 2. Every minute any fresh that is rotten orange, return the minimum number of minutes that must elapse until no cell has fresh orange. Until no cell has fresh orange. So basically 1, 1, 1, 0, 0, 1, 1, right? So this is a rotten orange. So you will keep rotting the oranges if you go down, right? So, so this you can go down like this. So 2, 1, 1, 2, 1, 1, right? So this will rot the oranges. So basically all the rotten orange will start rotting this. Or if there is this two, it will rot this one first. Right? Whichever is the closest, that will rot first, right? And when there is no minimum number of minutes, when there is no fresh element left, then that means all the elements are rotten, right? Or if there are still fresh elements in the cake, then that means that there are still elements left, right? So what we can do is we should start from the rotten element and then go in that direction. So from here, if the next element is 1, then only you will say that is 2, then you don't need to pick it. If it is 1, then only you will pick it, and then uh, And once you put it in your queue, you can mark it as 2, right? Because that has become rotten there now. Okay. So now whenever we want to do a BFS, so that in the next, so I'll put all the 2's first and then we'll start BFS from there. If the next element is not equal to 2 and is not 0, then that it is a candidate, right? Mark it as 2, saying that okay, this is rotten. And what checks you need to do is that if there is any element is any element is one is left, one is left. So this is a kind of a show multi-source BFS because as soon as our queue is empty, there are no more rotom elements to be explored. Then we are good, right? So all the elements that are getting rotten, so basically, okay, then I need to reset. Let me stop sharing and reset. Wait, fixing this thing. Okay, this thing. Okay. Okay, why this became small? Should not this. That we discussed. Okay. So basically, it is this is a BFS solution, right? So multi-source, basically multi-source BFS. Uh, what I need to do is basically here. So you have a queue because in BFS you need a queue to do BFS. Pressed OK. Then so you go into the grid. If now grid of I comma j is equal to 2, that means it's a rotation element, right? You add it into the queue right now. While queue dot size is not equal to 0, so minutes with minutes are 0, right? First minute, what all? So all these queue dot size, all these will be activating at the minute one, right? Foreign time is equal to 0 I less than 7 I plus plus and that is equal to q dot fold. Now it will go in all the four directions, right? Dx is equal to 1 comma minus 1 to 1 comma minus 1 0 comma 0 and now probably I'll say in time is equal to correct dot in time is equal to correct dot 0 dot length and as these are kind of irrespective variables I should initialize these on the top, right? Now comes the tricky part. Uh, so basically I have done that. Now I need to go into all the four directions, right? For int d is equal to d less than, because it can harm those, right? Int 2, let's say, let's make a 2 and make a 2 like this and it will be dx of d plus at of 0 dy of d is at of 1. So that is number 2, right? Now if 2 dot 0 is greater than 0 and 2 of 0 is less than 1 and 2 of 1 is greater than 0 and then 2 of 1 is less than m, right? Basically all are within bound if grade of 2 of 0 is 2 of 1, right? Now this is first things. If 2 of f grade is uh, equal to true 1, means for assurance which will get this minute, right? So it will get rotten in the next minute. This is 0th minute. So q dot add new int 2 of 0, 2 of 1 and grid of 2 of 0, 2 of 1 becomes rotten, right? Now this is already 2, so I'll not be considering it again, right? Now here you have already made minute plus plus. So if you had done this, if the size is 0, then you don't need to come here, right? Or let's say size was 0 and it never made anything on, right? So then you don't need to do that. Boolean made converted equal to false, converted is equal to true. So if converted, then only you do this. Now foreign I is equal to 0 less than grade dot length I plus plus foreign j is equal to 0 j less than grade dot length. If grade a comma j is equal to 1, so basically then you return -1, otherwise you return nil. Perfect. Passed in without errors. So this is multi-source BFS basically. Now I basically I know this is a very weird question to be honest. So basically you'll have to start from Pacific and then Atlantic, whichever I'm betting, and then you have to find which of both of these true, right? So that is how this question works. I don't want to do this. I want to do surrounded course. All these three questions I'll take, but I'll take a break of about 7 minutes, not 7 minutes, 3 minutes. So Time. Uh, 3 minutes. So, okay. I'll keep on adding all the links of these problems. All the string section. So a region is surrounded with cells if you can connect the cells if none of the regions are on the edge of the board. A region size is basically zero. So all the zeros that are outside that won't fall into this trap. All the other ones will fall. So basically you will need a DFS from 0 and mark them as Y, and then if element is not Y, then you mark all of those as X. So again, this is a DFS problem. As of now we have only learned two concepts, DFS and BFS. Okay, so I'll solve this problem. So for int I is equal to 0, I less than board dot length I plus plus for int j is equal to 0 is then board of 0 dot length j plus plus if I is equal to 0 or y is equal to board dot length minus 1 or j is equal to 0 j is equal to board of 0 dot length minus 1. That's the first check. And if board of I comma j is equal to 0, oh, right, then you do BFS on board LJ. Public void DFS char board int I int j int n is equal to board dot length int n is equal to board dot 0 dot length if I is less than 0 or j is less than 0 if I is greater than equal to 1 or j is greater than equal to 1 basically return if board of I, j is not equal to, then also you return, otherwise you make it something else, let's say y, and then you go in 4 directions, so I plus 1j. So there is a different way of doing this as well, but as I think this is okay, this is kind of readable also. J plus 1 and I minus 1, J minus 1, right? And once you have done this, basically return and then public return. So this will be made by for entire equal 0 less than third length, I plus plus 4 j is equal to 0, j less than 4 of 0 dot length, j plus plus if board dot I comma j is equal to is not equal to y, then you make that board of I j is equal to x, else you make that board of I comma j is equal to y, is equal to back into it. There is nothing to do plus, so basically you can do this. And now I need to do course schedule. So this is another problem. This is based on topological sort. Topological sort, the idea is that you use an degree concept, whichever has a degree of 0, like no incoming edges. So that means that A is B, right? A is required to do B. So B has an degree, right? So there is a dependency. So you use B's topological. So what is the definition of topological sort? Is a ordering where A is topological sort is a graph ordering where for every edge from U to V, U comes first, then V, right? So we have to see the definition of topological sort. Topological sort definition. The linear sorting in a directed vertex for every edge. Vertex U comes before V in the diagram, right? So that is the meaning of topological sort. What is this interview cake? This interview cake, data structure, graph. Deep threat topological sort. Mm-hmm. So this is the same tutorial. Now create how many website has that, right? So basically this will be an and this will be your prerequisite, right? So prerequisite, but it says that you have A. Okay. So you have AI to BI, which means that indicates that to take course you need to first take one. So basically adjust from A to B. So your U is the other one, right? So and we need to form a graph here, right? Now graph can be formed in different ways. Here I basically I need to know all the relationships, right? All the nodes, so I can form it in n are there and n are 0 to 1. I can form it in a so each foreign tries equals 0 and less than half less plus list. This is the graph. Foreign type P so this is V, this is U. If I want to do degree also, degree of 0. And this U to V, right? And sorry. And then count dot get count ID. Right? Now degree of Y equals 0. Q dot add. Right? So basically you need a Q. Q and target requires a topological sort. You need a Q. It reverse while Q dot size not equal to 0. And that is equal to Q dot power. And it is equal to broad dot get that. And degree of 2 minus minus equal degree of 2 is 0 Q dot add 2. So basically if you have taken all the courses and count is equal to 0 plus plus so return count is equal to and So that is how this will work. So let this also. Sixth problem. Course schedule. Course schedule. So yeah, that's where I'll end the stream, guys. I hope everyone enjoyed the stream. So keep learning, keep growing, keep solving the problems, and that's it.